Reproducibility is the ability of an entire experiment or study to be reproduced either by the researcher or by someone else working independently. It is one of the main principles of the scientific method and relies on ceteris paribus. The result values are said to be commensurate if they are obtained according to the same reproducible experimental description and procedure. The basic idea can be seen in Aristotle's dictum that there is no scientific knowledge of the individual, where the word used for individual in Greek had the connotation of the idiosyncratic, or wholly isolated occurrence. Thus all knowledge, all science, necessarily involves the formation of general concepts and the invocation of their corresponding symbols in language. Aristotle's conception about the knowledge of the individual being considered unscientific is due to lack of the field of statistics in his time, so he could not appeal to statistical averaging of the individual. Reproducibility also refers to the degree of agreement between measurements or observations conducted on replicate specimens in different locations by different people, as part of the precision of a test method. History. The first to stress the importance of reproducibility in science was the Irish chemist Robert Boyle, in England in the 17th century. Boyle's air pump was designed to generate and study vacuum, which at the time was a very controversial concept. Indeed, distinguished philosophers such as René Copyright Descartes and Thomas Hobbes denied the very possibility of vacuum existence. Historians of science Stephen Shapin and Simon Schaffer, in their 1985 book Leviathan and the Air Pump, describe the debate between Boyle and Hobbes, ostensibly over the nature of vacuum, as fundamentally an argument about how useful knowledge should be gained. Boyle, a pioneer of the experimental method, maintained that the foundations of knowledge should be constituted by experimentally produced facts, which can be made believable to a scientific community by their reproducibility. By repeating the same experiment over and over again, Boyle argued, the certainty of fact will emerge. The air pump, which in the 17th century was a complicated and expensive apparatus to build, also led to one of the first documented disputes over the reproducibility of a particular scientific phenomenon. In the 1660s, the Dutch scientist Christian Huygens built his own air pump in Amsterdam, the first one outside the direct management of Boyle and his assistant at the time Robert Hooke. Huygens reported an effect he termed anomalous suspension, in which water appeared to levitate in a glass jar inside his air pump, but Boyle and Hooke could not replicate this phenomenon in their own pumps. As Shapin and Schaffer describe, it became clear that unless the phenomenon could be produced in England with one of the two pumps available, then no one in England would accept the claims Huygens had made, or his competence in working the pump. Huygens was finally invited to England in 1663, and under his personal guidance Hooke was able to replicate anomalous suspension of water. Following this, Huygens was elected a foreign member of the Royal Society. However, Shapin and Schaffer also note that the accomplishment of replication was dependent on contingent acts of judgment. One cannot write down a formula saying when replication was or was not acquis. The philosopher of science Karl Popper noted briefly in his famous 1934 book The Logic of Scientific Discovery that non-reproducible single occurrences are of no significance to science. The statistician Ronald Fisher wrote in his 1935 book The Design of Experiments, which set the foundations for the modern scientific practice of hypothesis testing and statistical significance, that you may say that a phenomenon is experimentally demonstrable when we know how to conduct an experiment which will rarely fail to give us statistically significant results. Such assertions express a common dogma in modern science that reproducibility is a necessary condition for establishing a scientific fact, and in practice for establishing scientific authority in any field of knowledge. However, as noted above by Shapin and Schaffer, this dogma is not well formulated quantitatively, such as statistical significance for instance, and therefore it is not explicitly established how many times must a fact be replicated to be considered reproducible. Reproducible data. Reproducibility is one component of the precision of a measurement or test method. The other component is repeatability, which is the degree of agreement of tests or measurements on replicate specimens by the same observer in the same laboratory. Both repeatability and reproducibility are usually reported as a standard deviation. A reproducibility limit is the value below which the difference between two test results obtained under reproducibility conditions may be expected to occur with a probability of approximately 0.95. Reproducibility is determined from controlled interlaboratory test programs or a measurement systems analysis. Reproducible research. The term reproducible research refers to the idea that the ultimate product of academic research is the paper along with the full computational environment used to produce the results in the paper, such as the code, data, etc. that can be used to reproduce the results and create new work based on the research. Psychology has recently seen a renewal of internal concerns about irreproducible results. Researchers explained in a 2006 study that, of 249 data sets from American Psychology Association empirical articles, 73% of contacted authors did not respond with their data over a 6-month period. The first author published a paper in 2012 suggesting researchers should publish data along with their works, releasing a data set alongside as a demonstration. Reproducible research is key to new discoveries in pharmacology. A phase I discovery will be followed by phase II reproductions as a drug develops towards commercial production. In recent decades, phase II success has fallen from 28% to 18%. A 2011 study found that 65% of medical studies were inconsistent when retested, and only 6% were completely reproducible. In 2012, a survey done for Nature found that 47 out of 53 medical research papers on the subject of cancer were irreproducible. John P. Ioannidis writes, while currently there is unilateral emphasis on first discoveries, there should be as much emphasis on replication of discoveries. The Nature study was itself reproduced in the journal PLOS One, which confirmed that a majority of cancer researchers surveyed had been unable to reproduce a result. Attempts to reproduce studies often strained relationships with the laboratories that were first to publish. Noteworthy are reproducible results. Hideo Noguchi became famous for correctly identifying the bacterial agent of syphilis, but also claimed that he could culture this agent in his laboratory. Nobody else has been able to produce this latter result. In March 1989, University of Utah chemists Stanley Pons and Martin Fleischmann reported the production of excess heat that could only be explained by a nuclear process. The report was astounding given the simplicity of the equipment. It was essentially an electrolysis cell containing heavy water and a palladium cathode which rapidly absorbed the deuterium produced during electrolyses. The news media reported on the experiments widely, and it was a front-page item on many newspapers around the world. Over the next several months others tried to replicate the experiment, but were unsuccessful. Nikola Tesla claimed as early as 1899 to have used a high-frequency current to light gas-filled lamps from over 25 miles away without using wires. In 1904 he built Wardenclyffe Tower on Long Island to demonstrate means to send and receive power without connecting wires. The facility was never fully operational and was not completed due to economic problems, so no attempt to reproduce his first result was ever carried out. See also, references. Turner, William, History of Philosophy, Ginn & Company, Boston, Massachusetts, e-text. See especially, Aristotle. Definition, by International Union of Pure and Applied Chemistry. Further reading, Blow, Nathan S. A Simple Question of Reproducibility. From the editor. Biotechniques 16, 8 doi, 10.2144/000114117. It is interesting to note that at this moment of greater irreproducibility in life science, journals continue to minimize the space given to materials and methods sections in articles. Timmer, John. Scientists on Science, Reproducibility. Ars Technica. External links, Reproducible Research in Computational Science, Guidelines for Evaluating and Expressing the Uncertainty of NIST Measurement Results. Appendix D, Definition of Reproducibility in the IUPAC Gold Book, Reproducible Research Planet, reproducibleresearch.net, ctuning.org, Reproducible Research and Experimentation in Computer Engineering.